question 7. So calculate the velocity of c immediately after the collision. So conservation of momentum. So what's going on before the collision? The two momentums are 0.2 kilograms times the 4 for p, so that's mv for p, and mv for q is 0.3 times 2.5. So that's all the momentum prior to the collision. After the collision, we know they join, so 0. plus 0.3, these masses combine, and so our resulting velocity is our unknown. This allows us to work out the velocity is 3.1. Now, part 2a, we're being asked to work out the value of v0. So v0 is the velocity 0 seconds after the collision. In other words, as the collision occurs. So immediately after the collision. Well, that's what we've just worked out in part 1. So our answer for 2a, v0 is also 3.1, because that's exactly what v0 means. It's 0 seconds after the collision. It is immediately after the collision. Right, part B, calculate the distance c moves before it strikes r. Okay, so we need to work out the distance travelled. Now we have the equation for velocity. v0 we've said is 3.1, so our revised equation for velocity is 3.1 minus 3t squared. Now if we integrate this, when we integrate velocity we get speed. So speed is the integral of this, which is 3.1t minus t cubed. We've added 1 to the power and divided by the new power. Now the c is 0. The distance travelled at t equals 0 is 0. So c, I haven't forgotten c, I just realised that c, our unknown constant, is 0. Now substituting in when t is 0.3, we can work out that the distance travelled is 0.903 metres. Now for part C, find the acceleration of c immediately before it strikes r. So again, when t was 0.3. Now velocity, as we know, is 3.1 minus 3t squared. Acceleration is the differential of velocity, so when we differentiate this we get minus 6t. Substitute in t being 0.3 and we get our acceleration being minus 1.8 meters per second squared. Now for part 3, immediately after c strikes r, the particles have equal speed but move in opposite directions. Find the speed of c immediately after it strikes r. Okay, so afterwards they're going to be going in separate directions. So beforehand, so we've got this combined p and q. Okay, so now called c. So that has a combined mass of 0.5. We know it's travelling at a speed of 2.83, a velocity of 2.83. How do we know that? Well, we've needed to work it out. Okay, so what we're saying is the speed of c before it impacts into r. We use the speed. The speed calculation, 3.1 minus 3t squared. So we're working out the speed when t equals 0.3. So substituting 0.3 into the speed equation, we get the speed being 2.83. So the momentum of c beforehand is its mass, which is 0.5, times its speed of 2.83, its velocity of 2.83. Obviously r was not moving before the collision, so the velocity was 0, so I have not needed to take into account r before the collision. Now after the collision we do obviously have to take r into account. What happens to c? Well, its velocity is its combined mass of 0.5 times a minus velocity, because it's going off to the left, whereas our momentum of r is its mass of 1.5 times its velocity of plus v, because it's going plus v to the right, c is going minus v to the left. So multiplying this out, gathering it all up, I mean v is our only unknown, we can work out that v is 1.415 meters per second.